Good afternoon, everyone. Welcome to the most exciting part of the show, the afternoon session. I'm sure you guys are very, very excited to know that what we are presenting, all 20 of you. My name is Ravi Debral. I represent a company called as Oxiel. It's oxygen, carbon, silicon, and aluminium. Our mission is to make the base properties of all base material better, thereby supporting sustainable growth of mankind. We produced a very interesting molecule called as graphene nanotube. And by the end of this presentation, I assure you, you would see a lot of interesting application of graphene nanotube, and you would also see how graphene nanotube can add value to your composite products. So what is graphene nanotube? As you see in the video, if you take one atom thick sheet of carbon, roll it into a tube, in our case 1.6 nanometer approximately of diameter and 5 micron and higher length, that is something which is called as graphene nanotube or single-walled carbon nanotube. The arrangement of carbon atoms in this graphene nanotube is very special so that you get some interesting properties in these graphene nanotubes. It is extremely conductive, at the same time 20 times lighter than copper. In the tensile direction, it is about 100 times stronger than steel. It is extremely inert, up to 1600 degrees Celsius in vacuum. And it has got extremely high length to diameter ratio. When you take all of these properties and mix it into any polymer, you get an effect of its 3D network at extremely low dosages. That means sometimes at ppm level of dosage, you start seeing the properties of graphene nanotubes, which is conductivity and reinforcement. Now take a moment to think about the kind of design flexibility that you get in making a composite, in formulating a composite. You can add much more functionality to the same composite by using ppm level of nanotubes. Let's talk about thermoset application of nanotubes first. Generally, nanotube, the nanoscale additive has an addition level of ppm, would be difficult to mix in an industrial setup. Oxiel solved this problem by giving you not raw nanotubes, but concentrates and master batches of nanotubes in 5 to 10% dosages. These master batches, which are called matrix in the case of Oxiel, are easy to use. You can just drop them in your industrial lab or industrial production setup, mix them properly, and start seeing its property. Comparing it with some other conventional fillers like carbon black or additives like ammonium salts, which also give conductivity, nanotube give a unique advantage of possibility of giving a color, at the same time maintaining a very clean production facility, which is not possible if you are using carbon. Everything becomes black. I'm not very sure who's the fan of it. You also get preserved or sometimes even increased, enhanced mechanical properties. And every polymer chemist knows, as soon as you add a foreign material like carbon to your polymer, the mechanical properties go down. At the same time, you get a stable resistivity, which is stable not only across the time, but it is also stable across various humidity. So you can have your composite in north of Europe, or you could have it in a tropical location. It will show the same level of conductivity, which is very, very important when you're designing a composite part for all the regions and all the seasons. Since you add such a low amount of nanotube, you'll see a tint of it in black, but at the same time, the end part that you produce with nanotube, there's a possibility it would not be black. You could put colors in your formulation and start seeing colors. And it has very limited effect on viscosity and thixotropic-like properties. So you essentially, what I'm trying to say is, do not have to change The formulation do not have to change the mixing method too much. You can just use your industrial setup and adopt nanotubes. Presently, we have products which can be used in any kind of manufacturing setup for composites, from hand layup to SMC to filament winding to pultrusion. Now, as I promised in the starting of this presentation, nanotubes are not only a lab dream anymore, we have live cases, industrially optimized and adopted cases to present you. Today, I have my colleague with me, Mr. Jens Walters, who's regional manager with BUFA. BUFA, as most of you would already know, is a renowned name in composite sphere, composite industry. Jens would present you some real-life cases of nanotube adoption in composites. Jens.
Thank you. Thank you for the introduction, Ravi. Welcome to our common presentation. As introduced, I will show you some cases where single-wall carbon nanotubes are used. First of all, we have some cases of conductive J-codes. What is the motivation? Mostly it is about safety regulations. So the benefit by using nanotubes is that you need a really small amount. That means we can adjust really many different colors. So on the right, you see some examples. So this is a wide range. Also, we achieve high loss levels. By using nanotubes, we have a high batch-to-batch reliability. So we can match conductive properties, but also viscosity and reactivity properties at the same time. We have no compromise in application. So such J-codes can be applied by brush, by spray, and without any gases inside or pores. With this technology, you can achieve the same weathering performance as you know it for standard types. Another example is on the left. There you see a J-code colored in RAL 7032. Further applications we have in conductive resin. Again, the motivation is to achieve safety requirements. You could match high conductivity, but also a high chemical resistance at the same time. We have an easy processing of such resin. Due to the low amount of nanotubes, the viscosity, for example, is just slightly increased. In contrast to other conductive fillers, we have no contamination risk. Typically, we offer pre-mixed master batches. Typically, we offer tailored master batches. And on the right, you see that we offer often conductive resins and conductive coatings for projects. So it means you have not only a low surface resistance, but also a low resistance from inside to the outside of the tank. We are using this technology also to create conductive tooling J-codes. The motivation is again to increase safety, but also, and this time, efficiency. So if you have a conductive mold, you will have no discharges during demolding. This increases the safety. You will have no flashes. We also notice a much lower demolding force. So you need less force. The risk of any damages is much reduced. If you have mold surface that you grounded correctly, the dust adhesion is much more reduced. Also, the cleaning step goes much quicker. This generation of conductive molds is also with a high loss level, a higher loss level than all other molds that we tested. And last but not least, these kind of molds have also extreme chemical resistance as it is based on vinyl ester resins. On the following video, you will see the comparison of a demolding on a standard mold and also on a conductive mold. So on one of the molds, you should not see any sparks. At the end of the video, we demonstrated with a blue powder what happens to the dust if it's coming to a loaded surface or unloaded surface. And as you can see, the cleaning step on a conductive surface is much easier. So that was my final page for today. Feel free to visit us later at our booth. You can see the number over there.
Thank you so much, Jens. Those were quite interesting slides, and what was special about them is those are all industrial application right now working in the field, unlike most of the lab-based additives. Along with this, let me also present you some other possibilities and applications of nanotubes. Primarily, nanotubes are adopted very fast in ATEX or atmospheric explosive-based environment, wherever there you do not want sparks, wherever you want anti-static material. For example, in case of rollers and sleeves, you want to make strong rollers and sleeves, but at the same time, you don't want a spark generation when something passes over them. You can add nanotubes and have a thinner roller or sleeve, which is stronger, at the same time, doesn't produce any spark. The case of gel coat or mold coat, which my colleague Jens already shared. The case of pultrusion, this is very interesting because pultrusion, as we understand, is one of the cheapest form of composite. And you can also harness the power of nanotubes in such low-cost products and still get its property. So just trying to bust this myth that nanotubes are very expensive to adopt. No, it's not like that. You could also use them in something as cheap as pultruded parts. The sheet molded compounds, SMCs or BMCs, which are then used in things like junction boxes that you see here. It's important to mention here, and quite a unique advantage, that you can have colorful and bright junction boxes also that are easy to see by visual means. But if you were adding carbon or any such heavy metal to get conductivity, most of the time the end result would be a black junction box. In pipes, sewage or offshore pipes, GRP or GRE, it doesn't matter. And in hand layup or children playground equipments. Since humanity is at the core of our mission values, I'm very proud to say that we are the dossier leader in EU REACH. We are the first and only graphene nanotube company which has the compliance and can sell up to 100 tons per year in Europe. In US, we have EPA consent. We are headquartered in Luxembourg and have about 9 offices across the world. You will find our representative very near you wherever you are globally. If you have any more information that you need, you can go to our online pages. We have YouTube pages, we have TikTok pages. I don't know, we have a lot of pages where you can find these informations on. There is my email ID here. And if you have any questions for us, I'd like to answer them now. Thank you. I guess it's my cue to go. If you still have any questions, I will be in the speaker room after this, and you can approach me or visit us at our booth. It is hall number 5, F125. Thank you so much. Have a good day ahead.